Welcome to qnawire.
In this problem, we're given an acceleration of this form and asked to find the velocity and the position as functions of time. We're also given that the initial velocity, v of 0, is equal to 0, and x of 0 is equal to 0. And technically this is meters per second, and this is meters. Now, to get from acceleration to velocity, we integrate. So vx of t is equal to the integral of ax of t, and we're integrating with respect to time. And we also have v of 0 out here, but v of 0 is just 0, so this term doesn't yield anything. Plugging in our form for a, we get the integral of a times t minus b times t squared dt. And the integral of that is at squared over 2, this is the reverse power law, minus b t cubed over 3. Before we call this the final answer, we should plug in what big A and big B are. Big A is given in the problem, and it's 1.5 meters per second cube. So plugging that in, I get that Vx of t is equal to 0.75 meters per second cubed t squared minus, plugging in b here and dividing by 3, I get 0.04 meters per second fourth times t cubed. That would be your answer for Vx of t. To get just x of t, we integrate Vx of t. And so I'm going to integrate a t squared over 2 minus b t cubed over 3. I would have these extra terms over here, but they're both 0, so those will yield nothing. And when I integrate this and then plug in for a and b, I will get a t cubed over 6 minus b t to the 4th over 12, which will yield to 0.25 meters per second cubed. I'll wrap those in parentheses, times t cubed minus 0.01 meters per second to the 4th times t to the 4th. And so there's another part. We also have to figure out the maximum velocity. And to do this, I'm going to take my form for Vx of t here. I'm going to maximize this function. Ultimately, it's a function. And remember, when we want to maximize a function, we take its derivative and we set it equal to 0. And so the derivative of the velocity, Vx prime, is equal to 1.5t minus 0.12 t squared. And we set this equal to 0 to maximize it. Solving this for t, we can cancel t here, and then that makes it much easier to solve for t. We get that t is equal to 8.33 seconds. This is the time whenever the velocity is a maximum, but it's not the maximum velocity. To get the maximum velocity, we plug this time into v of t. And so v of 8.33 seconds is equal to, if you just plug this into this here and plug it into your calculator, you will get 28.98 meters per second. And that's the maximum velocity. And that's the end of the problem.